So for my final project, I decided to do a simulation of what Christmas lights might look like on a breadboard. The reason I chose to do this was really because I was putting up my parents' Christmas lights along their house, and I was thinking about it and analyzing, how would this work, and applying what I learned in the course. And then I realized that I might actually be able to show how the circuitry works on a breadboard. So the way that it works is when the switch is turned on, the current is allowed to flow through, and then the electrical energy that passes through the LEDs is converted into heat energy, which allows the LED to light up. Now I'm going to show you how each component works in the circuit. The components I have here are I have jumper cables, 4 LEDs, a 130 ohm resistor, and one single pole double throw slide switch. The way it works is when I already have the power source on, so there is already the only thing stopping it from turning on is the switch I have over here. So I'm going to go ahead and turn this on. And an interesting fact I learned about this switch is that it is actually you're actually able to use it to connect two different circuits. That's why it has 3 spokes. So what you could do is connect another circuit to the 3rd spoke, and then instead of turning circuits on and off, what it would do is if it switched to the left like this, then it would turn on one circuit. If it switched to the right, it would turn on another circuit that it is connected to. But I am using only 2 spokes. I connected one to the ground and one to the positive terminal so that it could light up my LEDs. I also used a switch and did not connect the LEDs directly to the power source because I wanted the switch to act like the timer that you might have on your Christmas lights, or sometimes some people would turn on their Christmas lights manually, like it's connected to a switch. So I want to have that kind of simulation. So when I turn the switch on, all the components light up. All the LEDs light up. The 130 ohm resistor is there so that the LEDs do not burn up. It regulates the amount of current and the voltage that flows through. I actually learned how important those resistors are when I was making this circuit. I had quite a few LEDs burn up, and a couple of them popped. That is, the ones that popped weren't because of the resistor. Those was because I put them in the wrong way. I reversed the where the cathode and anode are supposed to be connected, so they popped in my face. And it smelled like burning, but anyways, I connected these LEDs in parallel because if you think about it, when one light bulb in your string of Christmas lights gets busted, the rest of the Christmas lights are still working. So let's say that this bulb here gets busted, I pull it out, the others are still going to work. Because if you want your house to still look okay, even though there's one Christmas bulb that is busted, then you would want it connected in parallel. Also, it would not make sense to replace an entire system of Christmas lights just because one bulb is busted. It's easy to replace one bulb. The other component is, of course, the jumper cables. That is what connects what allows the ground to be connected to all of the LEDs. While the LEDs are connected in parallel, this is actually a series parallel circuit. I will show in my diagram later. It's in series parallel because the switch and the the resistor are connected in series. and then all the LEDs are connected in parallel. There's only one single path for the current to flow through until it hits the second LED. So all of this is in series, and then it gets to the second LED and the rest of the LEDs, then it turns into, that is the parallel section of the circuit. So here's a diagram that I drew for my Christmas light simulation. Here I have 5 volts written because that is the 5 volts that I got from the power supply. And then as can be seen here, current flows from the positive terminal to the switch, to the 130 ohm resistor, and then through each of the LEDs, which convert the electrical energy into heat energy, which allows them to light up. Like I mentioned earlier, this is a series parallel circuit because the switch and resistor are connected in series. There's only one single path for the current to flow through, and then it hits the LEDs, which provides more than one path for the current to flow through, making this series and then a parallel circuit.